Hello friends, I am coming with the standard and very interesting question of number 1 from Pathfinder Newton laws of motion. What is the wording of the question? Question is saying that a uniform rope of length 13 meter tied on a peg A on a wall passes over a frictionless peg B fixed in a level with the peg A as shown in the figure. If it is in equilibrium, length of the rope hanging between the peg is 8 meter. The angle which the rope makes with the wall at the peg A is closest to. So what the question is saying, this length of this, you can say that, I will tell you, this length is 8 meter. So you can say that this length is 5 meter. Okay. So for better understanding, I redraw this situation and then you will understand carefully. Suppose, my dear friends, this is the wall, and from this wall, a point A is here, and at this point A, the rope is hanging in such a way, like this, and at this point B, it is passing like this. Understood? So this is the scenario is given. What I tell you clearly, this for the better understanding, you can say that this rope is like this. Okay. So just listen carefully. At this point, one tension T1 is developed, and at this point one tension T2 is developed. Here also T2 is also developed. So I want to draw this free body diagram separately. So if this is let linear mass density of rope is lambda. So if the linear mass density of the rope is lambda, then this length actually 5 meter, I tell you. So mass of this rope is 5 lambda g. And if you cut the half of this, so this part of the mass is 4 lambda g, and this side of the part of mass is also 4 lambda g. Okay. If it is in equilibrium, so you can say that at this point, one tension T is acting in this direction, and here it is also acting in this direction. Understood my point? Okay. So now I tell you, just listen, if I want to draw this vertical free body diagram separately, then you can understand carefully. So this vertical free body diagram, one tension T2 is acting here, and 5 lambda g is here. So we can say that in case of equilibrium, the T2 is equal to 5 lambda g. Okay. And now I tell you one thing. If this angle is theta, my dear friend, listen carefully. If this angle is theta, so this angle is also theta. Understood? So T2 has a one component which is acting in this direction. It is T2 sine theta, cos theta, and one component in this direction, it is T2 sine theta. My dear friend, similarly T1 component in this direction, it is T1 cos theta, and here it is T1 sine theta. So if you see this half of the part, if you can consider this half of the part, and this half of the part is in equilibrium, so we can say that the T1 sine theta is equal to this T. So T in case of equilibrium, the T1 sine theta which is acting in this direction, which is balanced by this point, is source's tension is acting in this direction. So T1 sine theta is equal to T. And if you see this point, if you are talking about this half of the ring, this half of the rope, then you can say that the T2 sine theta is also equal to T. So from equation 1 and 2, you can say that the T1 is equal to T2. So T2 I already calculate 5 lambda g. So T1 is also 5 lambda g. Now in a vertical component, this is the balancing, and in case of equilibrium, so downward force is acting 4 lambda g and upward force is acting T1 cos theta. So we can say that the T1 cos theta is equal to 4 lambda g. My dear friends, if it is 4 lambda g, so this is T1 is 5 lambda g into cos theta is equal to 4 lambda g. Lambda g cancel out. Cos theta is equal to 4 by 5. That is means theta is equal to nothing but it is equal to 37 degree. So from A, the rope is closest to the angle 37 degree. So thank you so much for watching this video. Bye bye.